This is Concept 3 notes on population growth patterns, and just like Concept 2 and really the rest of this unit, all of the notes are going to be the same for CP and honors classes. Honors, you're just going to have more advanced assessment, so get excited. All right, population growth patterns. So just a reminder from Concept 1, population is a group of organisms of the same species living in the same place. So if we want to look at population growth, we tend to see two patterns. One is exponential growth. This is a population that grows without limit, and this is how the human population is currently growing. It's increasing without limit. Whereas the other option is logistic growth, the other pattern we tend to see. And this is when a population grows quickly at first. You can see it looks exponential at first, but then it levels off. This is how most natural populations grow. They have something called a carrying capacity. This is the theoretical maximum population that a given environment could support. So it's a theoretical maximum because it's a prediction and it can change. Let's say there's a ton of rain one season, so the grasses grow more. There's more food source for more organisms, so more organisms are living longer and reproducing. Thus, other organisms have more food source, so it can expand and raise the carrying capacity. Or there could be a natural disaster. There could be a drought one year and it could wipe out a food source, and that could decrease the carrying capacity. So we're going to talk about different things that could change the carrying capacity. So when we're looking at population growth, population density is a more effective measurement to look at, a more appropriate measurement to look at than just population. Population is just the number of organisms. Population density is the number of organisms in a defined space. So in terms of calculating it, honor students, you'll have to calculate this, CP you won't. But it's the number of organisms divided by the space. So it could be any unit. We could say the number of organisms per square mile, the number of organisms per square foot. It really doesn't matter what the unit is. Just watch your units as you do your division. So, and it's determined or it's affected by limiting factors such as birth and immigration. Immigration, think I stands for in. This is people coming into a space. So both birth and immigration create high population density. It makes it more dense in the defined space. Whereas death and emigration, think exit, create a lower population density. And these are kind of the four broad categories, but we can take these limiting factors and we can classify them even more specifically as density dependent or density independent, as biotic or abiotic. So we're going to do that now. We're going to really zero in on some limiting factors that can cause these. So again, limiting factors, these are aspects of an environment that limit the size a population can reach. They can be biotic, meaning living, or abiotic, meaning non-living. So let's think of some examples. Living things that could limit a population. Predators, if we have, lions eating antelope, I don't know. Lions are living things. They are predator the amount of lions can be a limiting factor for the elk population. So predation, competition, competing with another living thing for food, for mate, for living quarters. That's a limiting factor. Disease. Most diseases are caused by living things like bacteria, or they're spread through living things, so they're considered biotic. Abiotic would be things like natural disasters, flooding, forest fire, climate change, that kind of thing. We can also classify limiting factors as density dependent or density independent. Density dependent operate more strongly on large, dense populations than on smaller ones. So they're factors that are triggered by an increase in population size or crowding. So the more crowded or the more dense it is, the greater the effect these are going to have. So think competition. If you're in the middle of nowhere, Kentucky, looking for a parking spot, there's not going to be a lot of competition. But if you're in New York City or in Times Square looking for a parking spot, it's much more dense, thus the competition is going to be much more intense and much more limiting. Predation. The more predators there are, the more intense and the more limiting the factor. Same with parasites or disease. Disease spreads faster the more people you come in contact with than if you come in contact with less people. So these are all examples of density dependent. And you may notice they also all tend to be biotic factors as well. Whereas density independent are factors that regulate population growth regardless of size or density. So all species are pretty much affected equally by density independent factors. This is things like weather changes, pollution, natural disasters. So think like a tornado doesn't see New York City and decide to get bigger and grow bigger than it would if it hits Oklahoma. It doesn't grow in size when it sees more living things and more organisms there. So its damage is independent of the amount of organisms in the population density. So a stable ecosystem is one that remains relatively constant with predictable changes in population growth. So this is kind of like not a real thing. Things are never completely predictable because there can always be random environmental changes. But when we say stable, it's not completely constant. It's just if there are changes, they are somewhat predictable. They're following population growth patterns, that kind of thing. One last thing to talk about is survivorship curves. So these curves basically show the age in an organism's life and how many are surviving. So there's kind of 3 survivorship patterns that we see. So first is type 1, that's this blue line. So this is organisms that have lots of parental care, and so they're cared for throughout their lifetime, so they don't really, most of them die very late in age, so very old age. This is humans, people tend to have 1 baby at a time, maybe 2 or 3, and they put a lot of care into their child throughout their entire life to try to keep them alive. And so that's an example of type 1 survivorship. Type 2 is constant loss. So mortality is unaffected by age. So this is like some birds and rodents. So, they have a medium amount of offspring, maybe somewhere between, 5 to 10. And there's medium amounts of care. And so there's just kind of an even amount. Some birds die early, some die middle of life, some die late in life, but it's all just kind of even. Type 3 is early loss. This is organisms or species that produce a ton of offspring at first, knowing that a bunch are going to die right away, and then only a few will survive to live old age. This is like fish and mosquitoes and other organisms that lay a ton of eggs. Those are kind of the 3 types of survivorship. And that is population growth patterns, concept 3 notes.